Closest distance of approach.
Alright, so we're looking at the closest distance of approach today under physics. The closest distance of approach today under physics. Now, consider two moving bodies in a direction inclined to each other. There is a point where the bodies can get close to each other, and this point is called the closest distance of approach. Now, what do we mean? What we mean here is that consider that a body moves due east with a velocity of what? VA. And the body moves also what? Due south with a velocity of what? VD. Now what happens is that if you join the third one here, we can now find their resultant. So if their resultant is this direction, we have to negate this vector here, negative VA, and we can find the resultant as what? VBA. Now the resultant velocity. Now the resultant velocity VBA or velocity of VB relative to VA, we know is what? VB minus what? Minus the VA. But here since the VA will be negated relatively, then we can find the VB as what? VB minus what? VA, which becomes VB plus what? VA. Okay. But initially it will be VB minus what? VA. Now what happens is that when you draw this resultant vector over here, that is the VBA, from the point of the two inclined bodies, the two bodies that are inclined, from the two bodies where they started from moving, you can draw a line to meet the hypotenuse over here. So the line that is drawn perpendicular through the resultant velocity, and let's say, okay, let's label the point here as O, X, and Y, and this point as K. Now the line that is drawn perpendicularly to touch the resultant velocity, that is OK, is now referred to as the closest distance of approach. So now, to move this distance to touch the resultant, you can move the closest distance of approach to touch the resultant. So what it simply means is that if you want to start from here and want to come to this point, you have to move from here to this place before here. You have to move from here to this place before here. But you can have the closest distance of approach to the resultant vector in very simple. And now this closest distance of approach, how do we find it? How do we find the closest distance of approach? Now consider this very well here. So let's consider this. The VA, so the O, this is the VB, the VBA. So OY, this is the K, and this is the X. So consider that from triangle, let's take an angle here, theta. Let's take an angle there as theta. So from triangle OYX, 1, 2, 3, OYX, you can say that tan theta is equal to the opposite here, which is negative VA, but let's use the size, which is the OX, divided by what? The adjacent, which is what? The OY. The adjacent, which is what? The OY. Now, we want to use OK from this same idea. We want to use this theta to find the closest distance of approach. To find the closest distance of approach. And that's the distance what? OK. So now, if we want to find that closest distance of approach, OK, this same theta, from what we've gotten here, because from here we can say theta is equal to the tan inverse of what? OX over what? On OY. Alright, so now from here we can use the theta to find the closest distance of approach, OK. And when you do that, realize that this is perpendicular to this line. So if you draw that line over here, which is the what? The Y X, you realize that the O is perpendicular to the OK is perpendicular to the line YX. So now if you close it like this, the theta angle is here, and this is our point O. So what are we getting? We are getting the right angle triangle. And this is our OY side, and this is our OK. So to find OK, it's very simple. You can use sine. So sine of the angle theta is equal to the opposite over what? The adjacent. But take note that we already know the sine from this concept. We are using that theta. We already know the theta. We are using that theta. And what are we getting? Theta, sorry, our OK now becomes OY sine of the angle theta. And this is how we find the closest distance of approach in relative velocity. Now let's take one question and see how we can deal with it. Alright, so now this is a typical question. The question is that there is a captain in a ship X moving due east at the speed of 32 kilometers per hour and decides another ship Y south of X 300 meters away. Now if ship Y moves north at 40 kilometers per hour, we should calculate the distance apart of the two ships nearest each other. So sometimes in the question, we will not just tell you to find the closest distance of approach. So for this instance, we have to calculate the distance apart of the ships. So the main point here is what? Nearest what? Each other. That becomes the closest distance of what? Of approach. And now to do this question, let's put our parameters down and let's draw a schematic diagram of it, or just a non-scaled diagram of it. Okay, so now velocity of what? Ship X is what? 32 kilometers per hour, and the velocity of ship Y is what? 40 kilometers per hour. Okay, and since ship X is moving due east, so now let's draw it. The ship X is moving due east with what? 32 kilometers per hour, and ship Y is moving what? Due north. Ship Y is moving due north. I get it. Ship Y is here, which was at the south. So this ship Y. And this ship what? Ship X. So to get a question well. So that's ship Y. So the captain in ship X is moving due east. That's the ship captain in ship X. Sends another ship at Y south. So Y is south of what? Of X. But the ship Y is moving due north, this direction. Are you getting it? And the ship X is moving here. And it's 300 meters away from what? Ship Y. So X is 300 meters away from ship Y. So this is it. 300 meters away. So now, if we move it that, we should calculate the total distance of approach. And this is moving at the velocity of what? Ship Y is moving 40 kilometers per hour. So therefore, if we join this to this, we can now find the closest distance of approach, which becomes here. So now, if this is supposed to move this direction, this is supposed to move this direction, they can easily meet. That is the nearest distance apart from the two ships nearest to each other. Okay, and since we get this, how do we find the closest distance of approach? So let's label it. Let's say here is A, B, C, and D. So let's put an angle here as theta. Let's put an angle there as theta. So with that, we can easily find AC. But before that, you have to find what? The angle theta first. The angle theta first. So therefore, from ADB, from triangle ADB, you can say tan of theta is equal to what? The opposite, which is 32 on what? Adjacent, which is 40. Because here will be the right angle triangle. So therefore the theta here becomes the tan inverse of 32 on what? On 40. And theta now becomes 38.66 degrees. 38.66 degrees. But our focus here is to find what? AC. I get it. So therefore, this is what? D, B, and this point is C. And A is perpendicular to C. I get it. So D here is what we found now, which is 38.66 degrees. So now I want to find AC. So now AC, you know AD. AD is what? The distance of about 300 meters. So we want to find the closest distance of approach. So now we are calculating distance. So AC now becomes what? Sine is equal to sine of what? 38.66 times AD, which is what? 300. Do you get it? Because sine of the angle 38.66 should be equal to opposite, which is AC divided by the hypotenuse 300. So therefore the AC here, if you multiply this, you get 187.40 meters. And this is the distance apart of the two shapes nearest to each other. Thank you very much for joining.